Good evening, dear students. Today we will start a new topic, and that is called conic section. Okay. In the earlier few classes, we are done with point and straight lines and circles. So today we are going to start a new topic that is called conic section. Now the name suggests that it is section of a conic, isn't it, dear students? That is why it is called conic section. So before we proceed further on the analytical geometry on conic section, okay, which consists of parabola, ellipse, and hyperbola, I would like to give you the idea of this conic section in two, you know, different methods. Okay, the first method is related to the section of a conic. So that means if you have a double flapped cone and you chop that cone with a plane, then the way you are chopping it in that angle, the way means the angle you actually take with which the you are making the chopping means section, making that section of that of the double flapped cone, that gives you a different kind of curves which are sometime parabola, sometime ellipse, sometime hyperbola. So I'm going to show you one animated video now to so that if you look into it, you have a very clear understanding that why it is called conic section. These three curves, as I just said, parabola, ellipse, and hyperbola, why they are called conic section, and how these curves are actually getting generated by observing the cross-sectional view of that of chopping off that double flapped cone with a plane. So in the next few minutes, dear students, I would like to show you that the animated video. But before that, I just like to confirm that you are able to hear my voice very clearly, dear students.
Yes.
It's absolutely clear. Okay, and able to view the screen, right?
Yes.
Now I'm going to show you another screen, not this screen. So this is my digital whiteboard. So before that, I would like to show you the animated video, which is available in the online platform at conarclasses.com. So let me share that particular website, and as all of you have logged into it, you can also find it out. Just a minute. Let me share that screen with you first. I hope all of you are able to view that screen of conarclasses.com.
Yes.
So first you log in and give your login and password the way you have your login and password. So I'm just going with my demo login. Okay, after successful login, dear students, you go to the click under the right practice test, and then in the quick search by keyword, just write parabola. After selecting parabola, you just click into the find online material, and after that, dear students, you will get there are a lot of videos available. But look into this 3D animation, that understanding conic section by 3D animation. I'm just going to I'm just going to play this 3D animated video to have a very clear understanding about the conic section. Okay, and once that animated video is done, then I'll come back to the analytical geometry and explain you that how the same curves like parabola, ellipse, and hyperbola can be obtained by having the locus of a point subject to certain conditions. So first look into the animated video. So I'm going to play it now. Please confirm that you are able to view it very clearly, dear students. Yeah, all right.
Yes.
All right.
Conic sections. In this module, you will learn about conic sections. When a straight line intersects a vertical line at a fixed point and rotates about that fixed point, the surface obtained is called a double right circular cone. A double right circular cone consists of two cones joined at a fixed point called the vertex. The line that rotates about the vertex is called the generator, and the line that remains fixed is called the axis. A right circular cone has a circular base, and its axis is always perpendicular line from the center of the base to the vertex. The perimeter of the base is called the directrix. The lateral surface of a right circular cone is called a nap. A double right circular cone has two naps. The nap above the vertex is called the upper nap, and that below the vertex is called the lower nap. Also, the angle between the generator and the axis is called the vertex angle. Conic sections. If a plane intersects a double right circular cone, we get two-dimensional curves of different types. These curves are called conic sections. Depending on the angle made by the plane with the vertical axis of the cone, the plane can cut the cone in three different ways. Ellipse. When the plane intersects the double right circular cone in such a way that the angle between the plane and the axis is greater than the vertex angle, we get a closed curve called an ellipse. When the plane is perpendicular to the axis, the ellipse becomes a circle. Thus, a circle is a special type of ellipse. Parabola. When the angle made by the plane to the vertical axis is exactly equal to the vertex angle, we get an open curve called a parabola at the intersecting surface of the cone. Hyperbola. The plane intersects only one nap of the double right circular cone as long as the angle between the plane and the vertical axis is greater than or equal to the vertex angle. However, if the plane intersects the vertical axis at an angle smaller than the vertex angle, the plane intersects both the naps of the cone to form an open curve called a hyperbola, which has two disjoint curves. Degenerate conics. If the plane intersects the double right circular cone at its vertex, the ellipse becomes a point, the parabola becomes a line, and the hyperbola becomes two intersecting lines. The figures so obtained are called degenerate conics. In this module, you have learned that when a plane intersects a double right circular cone, two-dimensional curves called conic sections are formed. There are three types of conic sections: ellipse, parabola, and hyperbola. When the double right circular cone is cut by the plane so that the angle between the plane and the axis is greater than the vertex angle, the ellipse is obtained. When the plane is perpendicular to the axis, the ellipse changes into a circle. If a double right circular cone is cut by a plane, so that the angle between the plane and the axis is equal to the vertex angle, the parabola is formed. If a double right circular cone is cut by a plane so that the angle between the plane and the axis is less than the vertex angle, the hyperbola is formed. If a plane intersects the double right circular cone at its vertex, the figures formed are called.
So, dear students, what we observed with this is that the purpose of showing you this 3D animation is to understand that how the conic sections are actually formed, like parabola, ellipse, and hyperbola. Now, as long as the analytical geometry is concerned, we are going to discuss about these three curves, that is parabola, ellipse, and hyperbola, okay, by locus of a point. Okay, how? Let us going to discuss about it. Now, before that, I just want to confirm that you are able to view the screen now, that digital board, correct?
Yes.
All right, great. So we all learned about the called locus. Okay, so what we are going to do here, dear students, we are going to take one fixed straight line and one fixed point. Okay, so let me show you the diagram first. So what we are going to take is that one fixed straight line and one fixed point. So if you see, dear students, that straight line, what if you see this straight line I wanted to mean is that that is a fixed straight line. This straight line is a fixed one, and this is a fixed point. Okay, I repeat once more that what you see, that line, which is a vertical line, vertical to you, on which the point M exists, okay, that is called the fixed line, and the point that is what we consider as a fixed point. Now, a conic section or conic is the locus of a point P. And you see the point P, dear students? That point P is moving, but that fixed line, in fact, I can give that, name of that line, by the way. I can give a name of this line, suppose I called the line as called D1, D2, that is the line segment, for example, and this is the point S. So S is a fixed point and D1, D2 is a fixed straight line. Now the point P, what you see, that point P, that point is P is moving. And what you know about locus? Locus is nothing but, if you recall, it is a curve traced out by a point subject to some geometrical conditions. That is what we call as locus. Now here also we are going to discuss the locus of the point P and subject to the geometrical condition. What is the condition, dear students? Is that the point P is moving, but it is moving in such a manner that its ratio of distance from a fixed straight line, okay, and from a fixed point. So I repeat that the distance of that variable point P is such that the point P is moving in such a manner that its distance from a fixed point S, okay, is in constant ratio to its distance from a fixed straight line, okay, subject to the condition that the fixed straight line is not passing through the fixed point, which is obvious in this case. Means that straight line, what you see D1, D2 should not pass through the point S. Okay, if this is the condition holds true, so I repeat once more. So if I say this thing is that what SP by PM is constant. The point P is moving. The point P is moving, and D1, D2 is a fixed line and S is a fixed point. The point P is moving in such a manner that its distance from a fixed point, that is S, PS, is in constant ratio of its distance from the fixed straight line, that is PM. And when there is a distance from a point to a straight line, it is always a perpendicular distance we consider. So in simple term, what we can say is that the point P is moving in such a manner that we get PS by PM is constant. When we say that PS is in constant ratio of PM, that means what? That means PS by PM is a constant, correct or not? PS by PM is nothing but a constant. So now, then we can say what is that? That curve traced by the point P is a conic section. Now, whether the conic is in parabola or ellipse or hyperbola, that depends on what is the value of that ratio. That PS by PM, what is that value of that ratio? That defines what kind of curve will be traced out. Exactly what kind of curve will be traced out. So dear students, so let me write down whatever I have said so far. So let me first write down this particular point and let me explain you that what is meant by that. I hope all of you are able to view this particular, this one. So let me read out, dear students. A conic section or conic is the locus of a point P which moves in a plane so that its distance from a fixed point S is in a constant ratio to its distance from a fixed straight line, subject to the condition that the fixed straight line is not passing through the fixed point S. Then we can say a conic section or conic is obtained, means the locus of the point P, that means the curve traced out is a conic. Now, before I proceed further, what we can say from here, whatever we have, just, discussed. So we can say these are the three fundamental points. So what we understood is that we understood that, PS SP by PM is constant. Correct or not, dear students? So what we understood is that SP by PM is constant. So let me write it down here. Okay. Okay. So what we see is that SP by PM is equal to constant. Please note the following point. The fixed point, what I said, dear students, that is S, that is called as focus. Henceforth, that fixed point is called as focus. Focus is there for an parabola, focus is there for an ellipse, focus is there for hyperbola. Okay. The fixed straight line, okay, here the line passing through the point M and parallel to PM, and that fixed line also has a name, and that is called directrix. Okay. So there, so far we have learned two terminologies. One is called the focus. So this particular point S is called focus. And that fixed straight line, that is the D1, D2. So that is known as directrix. So let me write it here. Directrix, correct? Now the constant ratio, that SP by PM, that is known as the eccentricity. And generally it is denoted by E. So dear students, so far we have learned three terminologies. The first one is called the focus, that is the fixed point, that is called the focus, and the fixed straight line, that is called the directrix, and the ratio of that variable point, okay, from the fixed point by the fixed straight line, that is, SP by PM, that is called the eccentricity. Now, dear student, is that, as I said few minutes back, and I will repeat this once more, is that as the curve is obtained by the variable point P, we get, sometime we can say that curve as it is a parabola, sometime it is called, it is an ellipse, sometime it's called an hyperbola. Now that is actually driven by what is the value of E, means what type of value of E? It actually follows an inequality, and that we are going to discuss now. So depending on the values of T, sorry, they depend not T, it is E, slip of my tongue, dear students. So depending on different values of E, we get different members of the family of conics, as I'm going to show in the following table. And here it is, dear students. Okay. So if the value of E is equal to 1, that means SP by PM is equal to 1. Okay, for your convenience, I can place that image once more here so that you can just have a look into it. Let me place that image here once, this one. And dear students, what is E? E is nothing but SP by PM. E is equal to SP by PM. Now, dear students, if that value of E is equal to 1, we can say the curve traced out is a parabola. If the value of E is in between 0 and 1, that means 0 less than E less than 1, we can say the curve traced out is an ellipse. And if the value of E is greater than 1, then we can say the curve traced out by the point P is an hyperbola. So dear students, these are the three main sections, conic sections. But apart from that, as we are discussing analytical geometry, ratio can be near to 0 also. Why only these three values? 1, 0, less than E less than 1, and E greater than 1. It could be tending to 0 plus. If the E is tending to 0 plus, then we call that conic as a circle. And if that ratio is tending to infinite, then that what is the curve we are getting? In this case, we can say it is a pair of straight lines. Please note that E cannot be less than equal to 0. E cannot be 0 because ratio of two distances cannot be 0. Na? And also it cannot be negative. So with this, we cover all the possible values of E. So dear students, before I proceed further, I just want to tell you once more the values of E. Our primary focus is actually, the first three. That is when the value of E is equal to 1, that is called a parabola. When the value of E is in between 0 and 1, that is called an ellipse. And when the value of E is greater than 1, is called the hyperbola. The other cases are, these are the, for the sake of discussion of the values of E. But we will focus on these three, curves, the family of the members of the, names of the members of the conic family. As you see, it is parabola, ellipse, and hyperbola. Now, dear students, if you recall, when we discuss about that general equation of second degree, if you recall the general equation of second degree that we discussed during the study of pair of straight line, also we discussed during the study of, circles. So what is the general equation of second degree in X and Y? If you recall, let me read out, then I will write it down. The general equation of second degree in X and Y is something like that: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Okay. Now, that curve, that general equation of second degree, actually, it represents a conic. So let me write it down and then explain further. Let me, write it down, let me take you to the next page and explain, dear students. If you look into this particular, statement, dear students, A equation of the following kind is called a general equation of second degree in x and y. That is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, where a, b, c, f, g, h all belongs to the set of real numbers and not all 0 simultaneously. Such an equation represents a conic. Now, there is a fundamental question. Okay, how come we can say this conic is a parabola or ellipse or hyperbola, which is the most three important point of our discussion? That depends on the few conditions, and that we are going to discuss, dear students. The first one is that if we find the delta at a determinant, okay, how we find the delta? We discussed one of our previous classes is that there is a determinant. If you recall, there is a style of writing this thing. Just a minute. There is a style of writing this determinant, that A, B, C, F, G, H, and F, G, H. So let me show you once more by writing it actually. So how to write it down? So the way you need to write is that first you draw this one, then A, B, C will be in the corner wise, then F, G, H, and F, G, H. So we define the value of this determinant as delta. Now the above equation 1, that is the general equation of second degree in x and y, will represent the following members of the family of conics on different conditions as mentioned in the table below. And I am going to show you the table now. Okay. And what are the tables, dear students? I am just going to show you. Okay, if the value of delta is equal to 0 and h square is greater than equal to ab, then we can call it is a pair of straight line. Okay, if delta is not equal to 0, h is equal to 0 and a is equal to b, that is known as a circle. And if delta is not equal to 0 and h square is equal to ab, then we call it as a parabola. If delta is not equal to 0 and h square is less than ab, we call it is an ellipse. If delta is not equal to 0 and h square is greater than ab, that is known as hyperbola. So dear students, our primary focus in the last three. That means the general equation of second degree, as you see this one, that ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 will represent, as you see here, dear students, that ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 will represent a parabola if delta is not equal to 0. That means the value of the determinant is not equal to 0 and h square is equal to ab. Then we call it is a parabola. If delta is not equal to 0 and h square is less than ab, then we call it is an ellipse. If delta is not equal to 0 and h square is greater than ab, then we call it is an hyperbola. If you see, dear students, in the case of parabola, ellipse or hyperbola, in all these cases, delta is actually not equal to 0. That is for sure, that the delta should not be equal to 0. Now on top of it, if h square is equal to ab, then it qualifies to be a parabola. That means that general equation of second degree qualifies to be a parabola. Now if delta is not equal to 0 and h square less than ab, then the general equation of second degree 1 is actually qualifies to be an ellipse. If delta is not equal to 0 and h square is greater than AB, then the general equation of second degree 1, actually equation number 1, qualifies to be a hyperbola. So this is the way we can see that how a general equation of second degree qualifies to be a parabola, ellipse, or hyperbola. So dear students, whatever we have learned so far, we have learned some very interesting thing throughout the session. The first thing what we understood is that how a conic actually formed by when a plane is actually intersecting a double flapped cone, that we learned during the animation of the beginning of our lecture. Then we discuss about that how we can get a concept of that that conic about that locus of a point, that we have seen that by means of how locus is actually helping us to have a clear understanding about the conic. And during that discussion of that locus, we introduced with three terminologies, that is called focus, which is the fixed point, then directrix, which is the fixed straight line, and the eccentricity, which is the ratio of the distance of the variable point from the fixed point to the fixed straight line. That is, if PS is the distance from the variable point to the fixed point, that is focus, and PM is the distance from the variable point to the straight line, that is directrix. That is PS by PM, that is SP by PM is known as the directrix. Eccentricity. I repeat, SP by PM is known as the eccentricity. Now, depending on the values of this eccentricity, it qualifies to be either a parabola or an ellipse or an hyperbola. This is the second point we have learned. And then the third point what we have learned, dear students, is that just to study that the general equation of second degree in x and y, and we see that how a general equation of second degree can qualifies to be a parabola, ellipse, or hyperbola. Before that, what I can say, a general equation of second degree in x and y represent a conic. Now that will represent a parabola if the value of the determinant is not equal to 0 and h square equal to AB. It will represent an ellipse if delta is not equal to 0 and h square is less than AB, and it will represent an hyperbola if delta is not equal to 0 and h square greater than AB. Apart from these three, there are two more cases. If delta is not equal to 0, h is equal to 0, and a is equal to b, it leads to a circle. And if delta is equal to 0 and h square greater than AB, greater than equal to AB, then it qualifies to be a pair of straight line. But our focus in all these three. So with this note, dear students, I would like to conclude the class here today, because that is the most logical conclusion of understanding about the conic section. Now in the next class, what we are going to discuss, in the next class we will discuss about detailed discussion about parabola. That what is parabola, how a parabola is formed, what its equation, and different relevant topics related to parabola. So that is all about what I wanted to discuss about the conic section for today.